Testing, testing. Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. You might have noted that we have just completed the work on looking at diastrophism. And I mentioned that diastrophism is actually another very big topic when we're looking at the work on geography, especially physical geography and the building up of the land. If you can go back and you check our little booklet, the booklet that we have used for our content work, you would have noticed that we started off by looking at plate tectonics, and it also covered work on continental drift and etc. Then we looked at examples of plate movements, diverging, converging, and when plates slide past each other. Then we moved on to looking at work on volcanicity. That's mainly to do with how volcanoes are formed, the structures that volcanoes can be classified under, the types of eruption that occurs from different volcanoes in Papua New Guinea and also around the world. We also looked at volcanoes in Papua New Guinea generally, and the review you had yesterday or the last lesson should also give you an idea from the many different volcanoes we have in our country. We also looked at the subtopic of diastrophism. It's actually a big topic, it's a technical topic, and there is actually a lot more to learn from it. We've only looked at the basics and the introduction to the work on diastrophism. And on that topic, we looked at mainly folding and faulting of the Earth's crust. We are now going to move on to the next subtopic in our work in geography. And if you can make reference to your little booklet, you would have found that. We have not completed that booklet, which is the introduction to physical geography yet, because there is the last part that has to be completed, and that is the work on denudation or erosion and weathering. And before we look at the last section of the booklet on erosion and weathering, I'd like us to look at the topic on rocks. Okay, basically, again, rocks is a very big topic under geology, but we are going to look at very simple and basic information on rocks. And our main aim at the end of this particular subtopic on rocks is to be able to, one, identify the three main groups that rocks of the earth can actually be categorized under. That's one. And two, also maybe be able to identify the formation of those different or the three main groups of rocks. And the way in which we are going to actually go through in approaching this topic is we are going to go one group at a time, and at the same time we might be able to see the link between those three groups of rocks that we are going to actually study about. So we'll start off now with the work on our subtopic on rocks, and today our main objective of the lesson is by the end of the lesson we should be able to at least differentiate between the first grouping of rocks in terms of how they are formed. And we are going to start off by looking at the first group, which is igneous. They don't come in any order, but I will start off with the work on igneous rocks. Before we look at the work on igneous rocks, I'd like us to look at the introduction to the topic on rocks, and then I would like to look at the definition to what rocks are. You might want to do some note-taking. Okay, the introduction now to the work or the subtopic on rocks. It says here, from the information which I have maybe collected, many different rocks, they make up the crust of the earth. Rocks may be hard, like example, granite, of which we will look at later and find out what type of rock it is actually classified under. Or they may be soft, like clay. They can also be loose, like gravel. But these are just some examples. There could be many others we could use in this particular context. There is a great variety of color also in rocks. Their weight is different, or they differ, and also the hardness of the rocks are also different. It is worth actually knowing more about the study of rocks in order for us to understand the work that we are covering on physical geography, mainly landforms. And that is the reason for why we are going to look at that topic briefly. Rocks are actually made up of minerals. So if you look at, or if you pick up any type of rock, you might find, or you might be interested to know that rocks are actually made up of many different minerals. If you think of a rock as being like a fruit cake, are we all thinking fruit cakes? Okay, then the minerals which are actually represented in the rocks could be, when we're looking at fruit cakes, things such as the sultanas that you find in the fruit cakes, the cherries which are in the fruit cakes, the currants which are in the fruit cakes, with all the other ingredients that is actually used to making the fruit cake. For example, the egg, the flour, and the milk, of which they bind that fruit cake together. So if we look at rocks and the fact that rocks are made up of minerals, those different minerals we can actually make reference to something we know about, and that is of fruit cakes, and then all the different maybe ingredients that we put together to make up the fruit cake. Okay, similarly, if we looked at the definition, a simple definition to what rocks are, then on the monitor it tells us that rocks are simply a combination of one or more mineral, compact and consolidated together. So any rock you pick up, it might be interesting to find out what minerals are compact and consolidated to give you that solid mass, which is referred to as a rock. With that simple definition, then, we note that in our definition, the word minerals appear. Rocks are made up of one or more minerals compact and consolidated together. So what are minerals then? In the context of what we are studying, minerals are referred to as a naturally occurring substance. They occur naturally in nature. They are also inorganic compounds. They are not made of plants or animals. They are inorganic compounds, each with its unique crystal structure, and also possesses a definite chemical composition. And note also that minerals are almost always in a crystalline form. That doesn't say that they're all in crystalline form, but they're almost always in a crystalline form. And that is also, again, perhaps a simple definition to what minerals are. And I'll go through that again. Minerals are naturally occurring inorganic compounds, each with its unique crystal structure, and possesses a definite chemical composition, and also almost always in a crystalline form. And that's the definition to what minerals are. And it is those minerals which are in the rocks, which are compact, which are consolidated then to give you a solid mass, which is referred to as a rock. Okay, so with those two definitions then, we are ready now to move on to looking at the grouping that all rocks can actually be grouped under. And the grouping that we are going to look at would be of the three main ones, and they are the igneous rocks. All rocks of the earth can actually be classified under igneous, sedimentary, or metamorphic. And we'll start off with the igneous rock. We look at the definition to what igneous rocks are, and then we will look at how we can identify igneous rocks in terms of where they are actually formed. Okay, have you made note of the definition of minerals? Okay, then we move on, and this time we look at generally rocks in those three groups. For us to be able to understand also the different groupings of rocks, we should not take one in isolation from the other. We must ensure that we are able to see the connection and the relationship between one and the other. And the best way maybe to see that relationship is by looking at what we call a rock cycle. And on the monitor here, it gives you a general way in which we can also show that relationship through a cycle. But we will look at the cycle later on. This is only one way in which we can put that information, maybe to show us what we mean by the rock cycle. And there are also many different ways in which we can look at the rock cycle. But this is just a sample or an example of a rock cycle. In this cycle, it includes all the three different groupings I have mentioned: igneous, sedimentary, and metamorphic. And at the same time, it also includes the different process that takes place for the formation of those three groups of rocks. Okay, we will be looking at the rock cycle towards the end of that particular subtopic on rocks. Here is another way of presenting the same information, looking at the rock cycle again. And I've mentioned that we will look at the construction of the flow chart and the cycle towards the end of the work on the subtopic rocks. So we'll come to that later on, but to give you a fair idea on what we mean when we talk about rock cycle. Okay, and now to the work on igneous rocks. The information here might be too small for you to see, so therefore just a general structure on how a flow chart can actually be constructed to show igneous rocks and their formation into the two main groupings. Okay, we look at from the beginning to, we look at from the top here right to the bottom, and that information is made better for you here. We start off with the first grouping of rocks, igneous. Igneous meaning fire or born of fire. A definition to the first grouping now that we are going to start off with of igneous: they are simply rocks which have been formed from the cooling and the crystallization or the solidification or solidifying of magma, which then gives rise to one or more rock types according to the composition of the magma and the size, and also according to the site of its solidification. That is perhaps a long definition, but then it also contains some very important points that must be present for the definition of what igneous rocks are. They are formed from the cooling and the crystallization or the crystallizing or solidifying or solidification of magma. You go back maybe to the work we've covered on volcanicity. You remember the features: seals, dikes, laccolith, batholith, stock, lapolith? They are features, right? They are intrusive features, but they are formed from the solidifying of magma under the surface. When they solidify, they form those features. Once those features get exposed, they are also of rock type. So we are looking at the cooling, the crystallization, or solidification of magma, which, when that happens to magma, gives rise to one or more rock types, again according to the composition of magma and the size and site of its solidification. And this is important because from the site and the size also we can further subdivide the igneous rocks. So when I gave you the information on laccolith, batholith, lapolith, seal, dikes, and so forth, those were examples of intrusive features. So if there are going to be examples of intrusive features, there will also be examples of extrusive features. And for the extrusive features, it is looking at magma, this time coming out onto the surface, and when it solidifies, it also will form igneous rocks. So whether the solidifying of magma is under the surface or on the surface, it will still form igneous rocks. So when we look at the site, that then could be one of the ways in which we can further subdivide the igneous rocks. Okay, we've made note of this information. Okay, let's look at the table now. And this particular table should enable us to identify the difference between the two groups or the two ways in which we can actually divide the igneous rocks. igneous rocks can actually be further divided into two main groups, and the two main groups are according to their site of formation, where they have been formed. And I briefly told you that some igneous rocks are formed under the surface, some are formed on the surface. If you look at this table here gives you the place where the igneous rocks are formed, information, and then it gives you the geological event with the information, the size of the crystals, the information for both, then the rate of cooling. It also gives you a simple example of a type of rock for the first grouping and then the second grouping. And it also gives you the common minerals which are found in those simple examples that are given. Let's look at that information stage by stage and see if we can understand what is being presented there. Okay, I told you that igneous rocks are formed as a result of the solidification and the crystallization of magma, and it could be under the surface or it could be on the surface. Magma, which actually solidifies under the surface, becomes an intrusive feature. Intrusive meaning inside or under the surface. Any magma that comes out onto the surface then will become an extrusive feature. And extrusive meaning on the surface. So here goes, we now have two groups, intrusive and extrusive. The geological term or event that we can use to describing any intrusive activity or feature is plutonic. When we talk about plutonic, we are looking at intrusive features or event. On the surface, the geological event that we will use to describing the extrusive features then will be volcanic. So when we talk about volcanic, we are looking at extrusive. When we're talking about plutonic, we are making reference to intrusive. When we pick up a igneous rock, maybe any type of igneous rock, perhaps if we are able to look at, or if the crystals on those rocks are visible, we might be able to work out whether the rocks have been formed under the surface or on the surface. Sometimes it's difficult because we will need to get those rocks into the laboratories, and then tests will have to be carried out so that they can identify the minerals in them. Or sometimes you need to look under the microscope to be able to pick up the minerals. But let's check here. Usually when we are talking about the size of crystals in igneous rocks, the intrusive plutonic igneous rocks will tend to contain large crystals. The size of the crystals are larger in them. Whereas the extrusive volcanic igneous rocks, the crystals in them tend to be small or very fine. Why? Would someone like to tell us why you think the size of the crystals of the intrusive rocks are actually large, whereas the extrusive volcanic rocks, the size of the crystals are actually small or very fine? Anyone would like to have a go with this one? Just to give us an explanation of why you think there is a difference. Silo, thank you.
Because of the slow cooling.
Okay, very good. Because not only of the slow cooling, but because of the rate at which those rocks have actually cooled. Okay, and that will bring us to the next point. So thank you, well done. It has to do with the cooling process. The large crystals in the intrusive igneous rocks are a result of the fact that cooling has been slow. And because of the slow cooling, it means that the crystals have time to grow. Therefore, they are large. Whereas the extrusive volcanic rocks, extrusive volcanic igneous rocks, the rate of cooling is actually fast. And because of the fast rate of cooling, then the crystals did not have time to actually grow. resulting then in the crystals being small or very fine. On the surface, note, it's due to the exposure to the air, resulting in the fast cooling. So volcanic igneous extrusive rocks tend to contain fine or very small crystals because of the fast rate of cooling, whereas the igneous intrusive plutonic rocks tend to have smaller crystals, tend to have larger crystals because of the fact that the rate of cooling has been slow and the crystals have had time to develop or be formed. Shall we move on now to looking at a simple example? Okay, a simple example that we can make reference to, maybe we have learned about already in grade 9 and 10, perhaps grade 10 when you cover the topic on geology. An intrusive igneous plutonic rock, a simple example is that rock of granite. Granite is a simple example given for the intrusive igneous rocks. For the extrusive volcanic rock, which is igneous also, a simple example is that of basalt. So basalt is an example of a volcanic extrusive igneous rock. Granite is an example of a intrusive plutonic igneous rock. The other examples we will look at later on. Could we go back now to the definition that we covered on rocks? The definition we looked at the beginning told us that rocks are a combination of one or more minerals compact and consolidated together. So if granite is a rock and basalt is a rock, obviously they would have had minerals in them, compact and consolidated together to form those rocks. So let's look at the common minerals. There are also other minerals which are found in a sample of granite and a sample of basalt, but the common minerals which are found in a rock of granite are the minerals of mica, the mineral quartz, and the mineral feldspar. Those are the common minerals which are found in a rock of granite. The common mineral which are found in the rock of basalt are that of iron as a mineral, pyroxene, and feldspar. These are the common minerals. They are not the only minerals. There are also other minerals, but these ones are commonly found in all rocks of granite, the mica, quartz, and feldspar, and in basalt, the iron, pyroxene, and feldspar. Shall we look at some samples now of rocks which have been maybe put together for the igneous types? Here we have a sample, an example of a rock of granite. I already told you that granite is an intrusive plutonic igneous rock. You can see the black spots there. What do you think those black dots or spots on that rock are representing? Yeah, crystals, yes. Minerals in them, time for them to actually develop because it's intrusive. The crystals had time to actually grow. So granite, a sample there, an intrusive igneous rock. We have not touched anything on the rock of diorite, but it is also another example of a igneous rock, and it is intrusive. So that's the rock which is called diorite. Diorite is an igneous rock. It is an intrusive plutonic igneous rock. Let's look at another example of an intrusive igneous plutonic rock, the rock of GABBRO. GABBRO is also igneous rock. It is intrusive plutonic igneous rock. Sometimes it's going to be difficult for us to actually just look at a rock and identify what type of rock it is unless we are trained people like the geologist. Then we are able to work out. But even geologists will have to take rocks and put them into laboratories to actually test and prove that they contain those minerals. They match up to the different ways in which you can identify a rock to say that it is of that type. Okay, then we look at the extrusive examples. Lava is actually an extrusive feature formed from volcanicity. Here's a sample or maybe a photograph taken from one of those books to show the lava from a particular opening here. That's extrusive. So all those features on the surface, they're also solidifying off magma. Once on the surface, it becomes lava, which has been solidified, yes. You can see a patch of red here, showing that this area is actually very hot. Okay, other examples of extrusive volcanic igneous rock. A classic one that we've looked at maybe from time to time is that of obsidian. You will see that it's very fine. Hardly you can see those crystals in there, man. The rate of cooling has been very fast. So obsidian in Papua New Guinea, in areas maybe West New Britain and Milne Bay, some of those regions whereby obsidian has been used as a tool for cutting maybe knives, etc., in history of our country. Okay, that's an example of an extrusive volcanic igneous rock. Another example we've looked at already, that of basalt. Basalt is actually extrusive. These are just some samples that I've maybe thought might be worth showing for the examples of those different rocks. Another extrusive volcanic igneous rock is that of andesite. Andesite is the name of a rock. It is an extrusive volcanic igneous rock. There's a sample of andesite given on the monitor. Another example of an extrusive rock. This particular rock here, when we were looking at volcanicity, remember we did touch a little bit on it. It's referred to as pumice. Okay, the rock of pumice is an extrusive volcanic rock. It is an example of what we call pyroclastic materials. And pyroclastic materials are any materials which are ejected from a volcano during an eruption. And some of those materials ejected are also rocks of which they can be referred to as pumice. So you have pumice, a very light rock. It could float out at sea because of the fact that it is very light. Okay, then from what we have looked at already, we had the rock of granite, the rock gabbro. Granite and gabbro are examples of intrusive plutonic igneous rocks. Pumice, rhyolith, and basalt are examples of extrusive volcanic igneous rocks. Those minerals that I mentioned, which are found, common minerals which are found in a rock of granite. Here is a rock of granite which was put under the microscope, and then the minerals were able to be picked up, those three common minerals. Here it tells us that the magnification was times 16.5, enlarging it so that we are able to pick up. So here we have a rock of granite, and you can see the feldspar in this color here, the grayish color. Mica is this color here, and the quartz, it's that white area in this particular diagram. This picture here shows granite put under the microscope and then the minerals to be able to be seen. With the naked eyes, we might not be able to see those minerals. Okay, here is a sample of the mineral quartz. That mineral quartz, we said it is found in a rock of granite. Looks like chips, but it's actually a mineral. Okay, then we move on, looking at the common minerals in basalt. The three main minerals that I mentioned were that of feldspar, pyroxene, and iron. From the diagram here, the black spots, they represent the iron mineral. Feldspar is represented with the gray section on this particular diagram here, and pyroxene is the yellow color showing that mineral in a rock or a sample of basalt under the microscope. Okay, let me give you now the activity of which I would like you to also work on that activity for your homework. From what we have covered already today, we only looked at one of the examples of the three groupings of rocks, and that is the igneous rocks. For your homework and also for what I'd like you to work on, I'd like you to construct a simple flow chart, and that simple flow chart should show the relationship between the intrusive and the extrusive igneous rocks. I'll repeat again, the homework again, and the activity I'd like you to work on. I'd like you to construct a simple flow chart, and that flow chart should show the relationship between the intrusive and the extrusive igneous rocks. You check also that in your exercise book you must have a written definition to what rocks are, a written definition to what minerals are, and as well as that, a written definition to what igneous rocks are. And then you have that flow chart constructed. Okay, have you got that information for your homework? Okay. That will also bring us to the end of our lesson. Class, if you can now stand up. Okay, to the pilot teachers, our keyword is igneous. Good afternoon and thank you, students.